Okay, back to another late night go at this again. So I stayed here last night till about 3:30 a.m. to get this cylinder kind of roughed in square. Figuring out the whole location by dropping this drill bit back and forth here like this till you find the center point and keeping track up there what we were doing. So basic, I came up with the numbers here. We had 3290 going front to back, which would be the distance from these studs right here. So that'll be the center line dimension. And then the side to side dimension this way I had 275 and 3280. So I had a variable of 5 thou that way, but it was 10 thou. We got 10 and 15 thou in their numbers. So this looks like a square bolt pattern stock. You know what's on the cylinder right here, it's square. I went and measured a 61 case in back I was working on, and it's a square pattern within 5 thou. So the basic dimensions are either 3290 or 3285 is what the center lines are between this way and this way on the stock cylinder. That'd be, both directions. So if you started here and went 3.285 that way, you'd be in the center of that hole. You went this way, you'd be in the center of that hole. You went that on both directions, you'd be on this one. So that's called dimensional figuring. You start at a common down point and work to each hole. I want to add 1/8 of an inch on each side of the hole here to get for the spread distance this way, but stock dimension this way. The other way of calculating stuff is the center line dimensions, where you come from the center of the cylinder and you go out, and that spreads out equally. So I like that dimension better because it's easier to keep track of where you're at. When you add 1/8 inch, you get kind of confused on where you're at. So what I came up with was a bunch of calculations going by the smaller cutter size that I have here, the oversized hole here, and the standard stud size here. I worked everything all out with all the math. So basically, if I use average these two numbers out, I get 1644 for my half my center line dimensions. So that's going each way. Because you took the big number, divided it by 2, that gets you the center line. So doing that, I came up with that. The hole that was in here is pretty big. So it's 465. It should be a 7/16 stud, which is what that is. So it's 28 thou oversized. So that's a 14 thou offset to get your cutter from the center line over to the edge of the hole, because we've slotted out. So that's what that worked out to be. Now my cutter is undersized. So it's 420 instead of being 437 in diameter. So that's a 17 thou offset, which is 8.5 on center. Smaller, so you got to add that onto the number. So if you take all those numbers, 644, 125 for half the case split here, because that's 1/8 inch from each side, 1/4 inch total. Then you have 8.5 offset for the cutter. And I add an extra 5 in there for clearance, because I don't think I need 30 thou slop in the damn hole. I'd rather have a little bit tighter fitting than one that goes clunk, clunk, clunk back and forth. Just a little bit of clearance is fine, but I don't want a lot. So I came up with a number of 1.782. So I'm just going to round it up to 785. And the 643 is the number that we can use, or 644, whichever one you want to use. So it's 42.5 to 44 to 45, I mean. So you can be anywhere in that group. Will average out your two numbers. I'm a little bit tighter, so I'm trying to just keep things a little smaller. All right, but I can make that 44. Doesn't really matter. 1 thou ain't gonna kill us. That's 2 thou total, but whatever. So these numbers I got. Those are gonna be the XY dimensions up here. After I figure out what the center line of the cylinder is. Now I need to do this anyway because I need to bore out this case or this cylinder where it's all been squeezed in right here. So I got to recut that with a mill to get that area there cut out, and then I can hone it back around. So I need to get to the center of the cylinder anyway. So I'm going to use that dimensioning. So there's lots of different ways of figuring stuff. That's how I'm going to do it. If you had a CNC mill, you'd probably come off to dimensional measurement, not centerline dimensioning. Now, those might not be the right phrases, but that's the terminology I use because I know what it means to me. And that's all I really care about, so screw it. Okay, so that comes out of the hole there. Back this over to the center. Now, theoretically, if you go 1.644 or 643, so 63.5 in the middle of those numbers. Six, 643. And then there's another half. 643, not 663, dumbass. Okay. So I took my dimensions that are guessing where I was at, right up there. We put my number in plus an extra half. That should give me a real average of these two numbers here, which are those. Because see, it was 642 to 645, so 643.5 should be in the middle of both those numbers. That would be called an average. Theoretically, I should be right on center now when I swipe this on my indicator. So we'll see how far off we are. If I'm within a thou or so, we're doing pretty good. If I'm more than a thou off, we're off. So let's see what we're gonna get. We're gonna get something. I already see it's off. Okay, what do we got over that way? We're at 0 that way. Okay, we're good that way. This way, not so good. I was off in some dimension. Let's see, that's about 10, about 11th thou off. So you split that in half to get where we want to be. Of course, we got wear in the cylinder, doesn't help matters any. Go further down might help the situation a little bit. And that changes a bunch. One extreme to the other. 0, not quite 0. Alright, cylinder's out of round, so we're not getting a perfectly centered up hole, but we're within a half a thou. So when you sweep it around, we're staying pretty even now. So there you go. So I can live with that. Okay, so we wound up being 7447, which is on our number we wanted, and that one we're off by quite a bit. That's 6 thousandths off, which is our 11 off, 12 off. So I'm assuming that's because I had this 275 number and we got 290 over here. That's 15 thou difference, which would give you, we're showing 11 thou up here, so we're within that tolerance range. So that means my hole numbers are probably pretty close, but like I said, we're coming off of someone else's deal. Okay, anyway, right now I'm going to go ahead and zero this thing out because I am on center now. Boom, boom. So now I can go ahead and bore this thing on center to clean that up, and I can go ahead and move this off center and cut the holes bigger. So at least I got something to go by now. A lot of work for setup, and only takes a few minutes to do the cutting. That's normal. When I do the next one, I get to do the same thing all over again. Oh boy. Okay, so now, take the indicator out. Let's see how close we were here. We got 2 thou of difference here, so the cylinder's probably not quite flat either, I'm guessing. Let's see, we are losing 2 thou. Go in this direction. Staying pretty straight on that side. Same on that. In there. So only this side is got a taper in it, and why has it got a taper in it? Because someone beat the hell out of it right here on the side, and it warped the whole cylinder on that side. So plus that is where it wears. That's the wearing point. It's the thrust side. So there's a lot of wear in this cylinder. What a shocker. Beat up race parts are not square. That is really hard to believe. Okay. Alright, so I'm going to take my end mill. Try to leave out enough distance I can use it. A little bit of wobble, but not too bad. Okay, so now we need to go figure out what direction we're going to go here. Okay, we are going to go this direction wider, stock this direction. So that means this one here we go to our 1643, 640, whoop, or 44, whatever you want to call it. Split the difference. 38. 643 and 8/10. That's pretty close. Okay, now if I go this way, we have my calculator here. I gotta do a little test. So we're going to be adding 8.5 thou to our 14 thou here to our number there. So 1.644 plus 0.014 plus 0.09 equals 748 should be the edge of the hole. Let's find out. 1.748. That doesn't make sense. That doesn't make sense at all. This number's too big. 0.748. No, that's not right. Right there we hit 668. I'm 100 off on something. So where did I come up with my air? Somewhere I got an air in there. Probably gonna be half the cutter. I'm doing something wrong with half the cutter probably. Yeah, whatever. We know what we need up there to make it work. So 668 is where we're hitting at right now, up there. And this on a hole bigger than I want it to be. So we're gonna cut that back by at least 8. Be 16 off. Yeah, that'd be about right. It's 30 thou over. So 16, yeah, that'd be good. So look like 660 is the number we have right now. So I'm not sure where my number error came out. What was our original one? 785. So if we take our 1.785, that's the number we had right there, we minus the 643 number, 1.6, oh damn it, closer, 1.785 minus 1.6435 equals 141 and a half, 141.5. How am I coming up with these numbers? See what tire does for you? What the hell is that number? That'd be 283. You double it. I don't know what that number is. Oh, the offset's the 1/8 of an inch. 125, but that's still too big for that. I have no idea what that is. So much for math helping me, right? Okay, well we know it's 668. I'm gonna go check this and see if it's 668. Somebody can go through all the dimensions and figure out where my error is at, because there's an error in there someplace. I don't know what it is. Okay, all I know is we're going to hit this one pretty quick. $654. $660. We hit. Alright, so 660 we're hitting, the other one was 668. So the hole is off slightly, but see this is a manufactured part, there's air and stuff. So there's a 4 thou offset and air issue difference than what it should be. Alright, so if you take the 1.660, 1.1660 times 2 equals 332. It doesn't, the numbers aren't coming in where, they're not working in my head. I should be able to back figure this and know what the hell I'm doing, but I'm not, something's not right. I'm screwing up something. So the diameter of the cutter is different here. There's an offset change of 8 thou, which you would have to subtract off of this number. Yeah, it doesn't matter. Here's the number I care about, right there. We're going to take 1.660. Screw all the math, I don't care. 1.660. Pen doesn't work very well. We add in a 0.125 to this number. Actually, I'm going to say 5. I don't want to go too far. Well, we already had 8, 5. Yeah, who knows? We'll figure it out. That's going to equal 1.660 plus 0.12 equals 1.780. 780. That's my offset number we're going to use. And there it is right there, 1.785. So what the hell? It came back to my number. I don't understand. Yeah, whatever. screw it. It doesn't matter. Okay, so somewhere between 780 and 785 is the number I'm shooting for up there.